Hello, it's David, and well, I have a Frontier problem. I mean, I do, but that's not what I meant. No, this is my Frontier problem here. This is the Amiga 500 that I've shown on my channel previously, and when I want to run Frontier to demonstrate it or to test audio on my A500 here, I get this error. What's all this about? What a pain. Well, I'll tell you what this is about, and it's actually a hardware issue. This is an Amiga 500. It's a 512 kilobyte machine. Frontier requires 1 megabyte. And when I first got this Amiga, and I linked the video in up here, it came with one of these in the trapdoor. This is a 512K expansion, which brings the total memory up to 1 megabyte, which is what's needed to play Frontier. However, it was quite severely battery acid or alkali damaged. I think they're nickel cadmium rechargeables, and they leak and they make a terrible corrosive mess. So I removed the battery and I socketed these 4 chips, but I made a pretty abysmal job of it, I can tell you. Now, one of the things I've said on my channel a number of times is that I am terrible at desoldering through-hole components, and when they are battle damaged from battery leakage, it makes it even harder. And well, I attempted to do it with these. I didn't do it on camera. I attempted to do it with these 4 RAM chips, and oh my word, what a mess was made. Pads missing all over the show, really unkempt bodge wire in there, and I don't know if you can pick that up. Probably you can just about see it in that from that angle. That is scorch mark from me attempting to shift things with hot air and basically roasting this board. Now, I thought that this board was pretty much throwaway anyway, and I'd get a new one if I broke it, so I didn't see the harm in practicing on it. And remarkably, with just a single bodge wire there, these 4 chips continue to work. They're now happily in sockets, but I sort of declared at that stage this switch was a goner. That's just now permanently jumpered on. I've not yet sourced a replacement battery, but yeah, we could probably, I think all the pads are gone from that side, but I think we've got a trace here, so that would probably work. But you can still see that this real-time clock chip here is crusty burger, and I think if I really want to, what's going on with this cap? He's seen better days. But I think if I really want to use this RAM expansion in anger, then I really need to bite the bullet and to have another go at it. This time I thought I would try and document it and show you really why I'm not lying when I say I'm terrible at desoldering through-hole components. I'm also hoping to gain a bit of experience because I've got a much larger desoldering project coming up, and I would really not like to damage the board. Look at that one, goodness me. For example, I would quite like to socket the CPU on my Mega ST, and what I would not like to do is to damage that because it's such a pristine machine. I could resort to clipping the legs off again, but I'm trying to preserve the CPU on this one if I can. So I need as much practice as I can, and I don't think it's going to get much harder than this. PCBWay. Not only do they sponsor this channel, but they also make quite excellent PCBs. Unpopulated and fully built options are available. They offer CNC machining, 3D printing, sheet metal fabrication, and injection molding too. If there's anything you're building, why not have a look at PCBWay.com, linked in down below. Whilst you're there, have a quick look at the shared projects section. You'll find quite a few of my builds there available to either download or order completely assembled. So thanks to PCBWay, and on with the video. Okay, so I think there's probably going to be a few different approaches we'll need to try here to free this up. We'll be using obviously normal soldering iron. I should probably have to resort to some hot air, and I'll bring in the ZD 915, I think it is, desoldering gun here that you've seen on my channel previously, and that I hoped would solve all of my through-hole desoldering issues. But turns out it wasn't that, and I only wish there was some idiom involving the quality of a workman and his opinion of his tools. But anyway, it needs a bit more practice, like I say. So we'll try and take this one off, we'll clean up a bit, and we'll pop on one of these new sockets here. Maybe even we'll look at things like these resistors down here. This doesn't look in the world's greatest state, and I think possibly those two caps are in line for replacement. I did those ones. I say we, I didn't record it. I did those ones, so I'm sure we can find some more of those. Let's let's start off with a boatload of flux and add a bit more solder. I may have chosen a bad time for this project because I think I've just run out of flux. And I thought I had another packet, but I cannot find it anywhere. I've got this liquid stuff here, but I've always found this pretty rubbish, to be honest. It evaporates in next to no time. I have some plumber's flux, but you have to be incredibly careful with that because it's pretty corrosive if you don't clean it up straight away. First things first, bucket loads of solder. Gosh, that's really not flowing, is it? Right, I think I'm having to resort to the plumber's flux, and I will have to make sure this gets a damned good scrub afterwards. But the advantage is that I have absolutely boatloads of it. Let's try that again. Certainly makes a difference on the flowing. Although, gosh, some of those pads do look in terrible, terrible nick. Okay, so the soldering gun appears to be clear. I'm just going to go down one column to start with, and I've resolved not to go above 400 degrees on the desoldering gun because I think we will lift things. So I'm starting at 390, which I'm hoping will be pretty much as far as I need to go. How to position this? Let's have a try. That didn't come away too terribly. That one looks a reasonable start. Big old power line, this one. And you'll notice I run the pump after removing, for a second or two after removing the gun from the board, because that's how you get clogs. Basically, you need to make sure that it's still pulling whilst it's molten. Not feeling a lot of movement, I'll be honest with you. But under close inspection, yeah, most of the pins don't look too bad. That second pin on the thick trace, that maybe still needs a bit of persuasion. solder works hot. Who'd have thought? Ah, in fact, there we go. One side is lifting. I wasn't expecting that, to be honest. I probably applied more force than I planned to there. I hope I haven't lifted a trace. Or torn out a through hole, a bit of through hole plating. Yeah, I have. I've lost. That's annoying. Don't know if you can see that. That one there, that's a bit of through hole plating attached to that, although it does look like it is corroded away. So yeah, some bodge wires are going to be required. Oh, something's popped up one end. A little bit of movement. It's very hot on my fingers, I can promise you that. I think I can see another pad coming there. Oh yeah, we've lost another one. I think I would have probably been better to put that in a PCB board before trying that, wouldn't I? I was spending half my time chasing it around. Okay, well, I can see there's the one bit of through-hole plating, and the vial on the top there that we saw was taken off beforehand. And on the far side, you can see, yeah, unfortunately, I've done the same with those two power lines. I think those are the power lines on the top there. Yeah. Well. So it turns out I still suck at this. My only positive, it's not even a positive, the only excuse I can offer is that it was corroded quite badly from that battery. But I think, truth be told, I do still need quite a bit more practice. Yuck. Okay, so while that is drying up from a jolly good scrubbing, let's turn our attention to the real-time clock chip here that we've taken off, and look to give this a bit of a clean up. So as discussed, I think we've lost two sets of through-hole plating on these two pins here, and one, there we go, on the side there. So we're going to have to sort that out when we come to refit it. But having a look at the data sheet, so we've lost pin 1 and pin 2. I think pin 1's a non-connected STDP. I don't know what that means. Chip select, I believe, is tied permanently to ground. So that has a big bar, I think, that goes to pin 9 there. So that will probably just needs to be jumpered underneath. And the other one I think we've lost is, let's have a look, pin, what are we, 1, 2, 3, 4 from the bottom, so that's D1, okay, one of the data lines. So yeah, we will have to look at fixing that one up as well. Well, I should have waited just one more day, because my flux paste nightmare has been relieved. My paste has actually arrived today, which would have saved me an awful lot of worry about the whole cleaning situation if I had just hung on another day. Such is life. Right, let's give these legs a bit of a clean up, see how they look after a bit of braiding. The ones with actual through-hole plating stuck to them, that might require manual intervention rather than just a little bit of polish. It seems to be running off a little bit. Yeah. There we go. There's the remnants of the through hole on the bottom. Same trick on the other side. I think that'll scrub up relatively well. Now, doing the inside is a lot trickier. I'm not quite sure how I'm going to tackle this, to be honest. Right, let's flood that again with IPA and we'll see how that turns out in the wash. It doesn't look too bad, I'll be honest, but I think a little bit of buffing is probably still in order. This is the wire brush, it's a little bit more aggressive than the fiberglass brush. Just want to be careful I don't actually bend any pins here. I think actually that's okay like it is. Let's just give that another bit of a soak as well, and we'll go back to the board. Okay, that's come out looking pretty reasonable, I think. Actually, you know, scorch marks and terrible bodge wire aside, the back of the chip that we removed is, I think, in very good nick. But yeah, the problem's over here. We obviously know that we lost these two pads. Now these are VCC, all three of them. Shall I say, but we lost them? Might have to buzz those out. Definitely lost pin 1 here. I don't think we have lost that actually, no. Yeah, sorry, anyway, ignore me. We've definitely lost pin 1 here. That one is not used, so that's fine. We've lost pin 2. Now that is the ground. That's actually, it's not ground, it's an input. That's ground down there, and that connects to that. So that's a fairly simple jump wire that we can do. The others don't look brilliant, but I think they're actually probably intact on this side, and they're definitely intact on that side. And there's no traces running on the top side, so that's absolutely fine. The only one that is a problem is over here. This is this D1 line that we talked about. That is a goner. There is no pad there, and the trace is on the top. So I think I might have a little go at trying to run a jump lead through the hole and attach it onto there, and then put the socket in, and we'll see how we get on. I think everything else can be repaired on the bottom side. So that's my plan, but otherwise this is cleaned up very nicely, so I'm not too worried at all about all of that plumber's flux. Now I don't have my battery holder yet today, so that'll be when things come along next time. I need to work out where we fit a diode to prevent charging. There's a diode here. I'm not sure what this does. We'll have to have a look at let's see if we can work out what the schematic is. But for now, let's look at fixing this pad and getting a socket in place. Okay, my first plan is to just try and work away the solder mask here on this trace, just out adjacent to the pad. And to do that, I'm using a cheap child's toy dart, which has a nice sharp point, and I'm not worried if it gets dulled or worn out, etc. You know, some people use multimeter probes, some people use tips of knives, some people use grinding, engraving tools. I don't have an engraving tool. I don't want to really use a knife, it's not accurate enough. Well, I don't have an X-Acto knife, and I do not want to go in blunt force with a screwdriver, so we'll give that a go. I'm just trying to get myself something to solder to there. There we go. Right, and now a little bit of an experiment. Can we actually fit a socket into the holes available with any clearing. So here we go, we've got ourselves a DIP 18 socket. Just going to see whether that slots in. The problem with these ones, these are dual wipes, that if you just whack them, squash them, and they're blocked, the pins will pop out. So you've got to be absolutely sure that everything's seated properly and that all the pins have come through on the bottom side, which they appear to have done nicely, actually. Excellent. Right, so one of these pins along here is the issue one. I think it's 4th, isn't it, from the end here? So 1, 2, 3, 4. This one. Now you see there's a slight gap down the side, and now my theory is we can probably fit a resistor leg, or something of that ilk, down through that hole, turn it through 90 degrees and tack it here, and basically provide something to solder onto at the other end. So I'm going to try and shape an old resistor leg, and we'll see how we go. Okay, so here is an old resistor leg bent through just beyond 90 degrees to give us a little bit of downward pressure. I'm going to slot that in there, and I'm not going to do anything with it at the moment other than just sit it like that, so that it's hanging out the back, floating around. As you can see, it's obviously far too long. Trim it down after soldering, I think. I just want to see whether the socket will still fit in with a little bit of an obstacle there in the hole. And I think it will. And there we go. You see, we now have something to solder to on this side. So that's the plan. Let's I'm just going to bend that through 90 degrees underneath to get that out of the way, and let's see how delicate we can be here. There we go. I believe that's okay. Mop up that big blob of flux quickly. I'll just have to try and chop the edge of that off in a moment. Okay, so here we go again. Let's try and drop the socket into place. A little bit more resistance there now. So I'm going to put my thumb on the top to stop the pin coming out. No, it has come out. You see, that's the danger. Okay, so may need to manipulate that a little bit. So where previously that fitted down nicely, it's now offering resistance. No, I lost the bind again, and actually what it's done is it's lifted that trace, presumably from where the heat and corrosion had worn it away. So I think we will just resort to a traditional bodge wire on the underside. So we'll take out our little resistor leg. We'll clean that back up, and we'll just solder the socket in and fit a traditional bodge wire. $100 nanofarad, 104. Slip it down there. And there was a second one at the end here. could have flowed better. There we go, that's pin 9 and pin 2 joined together. Those are the grounds. So yeah, where have we got to go for the next one? 10, 11, 12, 13. Pin 13 goes to this one here, which is 1, 2, 3, 4, 5, 6, 7 from the end and the nearest the edge. 1, 2, 3, 4, 5, 6, 7. Okay, there. That's our pin, I believe, of interest, which is the first one where the trace is on the top side rather than the bottom side. Right, I don't like this one here either. This is a fairly terrible job on my part. So I think what we'll do is we'll untack one end of this and try and straighten this up a little bit. Well, I think it's fair to say that that is spectacularly inelegant, and I had forgotten just how much of a hatchet job I had made on these solder pads under here. This is quite abysmal. It's so terrible that I don't know if you can see this, even the connector is frowning. Well, quite remarkably, despite all of the indignities this poor little RAM board has had inflicted on it over its time, from corrosion to scorching to the physical assault that I've enacted on it, to the complete disregard for aesthetics in my repairs, well, it does still work, or at least the memory component of it does here. So 0.5 megabyte chip, that's normal for the A500 on the board. Slow 0.5 megabyte, that is our expansion board, and I believe there's a way of testing that specifically. List all memory regions. There we go. That's us, I believe. C00000 to C7 FFFF. 0.5 megabyte of slow. Yep, there we go. What happens if I press that? Test memory range. There we go. That is testing only the expansion. Now, of course, what we don't know is whether the real-time clock chip there that I just worked on does work. Yeah, no clock detected. I need to check my bodge wires there, I think. Never be afraid to check your work, boys and girls. And it gets worse. Do you remember we're supposed to be soldering to pin 2? That's not pin 2. Nope. That's actually quite lucky that I didn't solder that properly the first time, because that is, I believe, 5 volts, and that is, I believe, ground. This end there's a slightly offset pair of pins, which is not from the chip, that is the capacitor, but at this end these ones are actually part of the chip. They're not additional capacitor ones. I think I got carried away with this massive trace here being pin 1 and 2. No, there's pin 1, the square one. Finally, Let's give it a try. Okay, well, we've got clock detected at DC 0000. Obviously the date's, well, it's only a couple of years out, which is quite surprising, but obviously it's nonsense. Let's do reset, set date and time. Obviously it's not going to actually be battery backed here, so it won't survive powered down, but we could always give it a reset. So well, you know what, I'm just going to set it to Christmas Day. Oh, why don't we do 11:45 and 30 seconds. There we go. Escape, save and exit. That is ticking nicely away, and let's do a control Amiga, and we'll see whether it reads back the same. I wonder if I power it down for you know, only a few seconds, whether it would remember that. Where are we? F8, there we go. 2307, no, I had 23, didn't I have 2345? And it's December the 27th, and it's 2046. Aha. Yep, my mistake again. This pin is not supposed to connect to this pin, it's supposed to connect to this pin next to it. So I have once again gotten off by 1 hour. Rats. Okay, I can see that the you can see the trace that I scraped away there, that's the one of interest, and that goes, I believe, to this socket here. So let's attach that to my multimeter and just test that that goes to, yep, that exposed trace. So that should be our pin here now, and it should not be any other pins on here. Great work, David. Invalidate time needs a reset. Yes, let's try again then. So we're going to reset with an F1. Ah, that's a notably different time to what we saw previously. That's good. It is actually counting on the correct time now. So let's give that the old reboot. Monday, April the 1st, 2024, and it is 12:10 and 12:11. Perfect. So another day has passed, and my CR2032 button tail holders have arrived. Although it turns out I'm completely out of CR2032s, so I'm going to have to make do with a CR2025, which does fit because they're quite well designed little holders. But yeah, slightly suboptimal. Anyway, got to get myself one. After the absolute debacle that was my bodge wire fitting on this, and you know, just general desoldering performance, I thought I'd spend a little bit more time working out what I will actually have to do here. So the battery pads here, this is the negative side, where I don't know if you can make that out, it's lost all of the padding there, but there is a little bit of through-hole connection down there to what was once a switch before the corrosion got it. That's the negative terminal. The positive terminal does exist there, so the negative just goes straight to system ground. That's absolutely fine, but the positive does not go to plus. That is, I believe, plus 5 volts. There, that's the plus 5 volt. Yep. So it does not go straight to plus 5 volts, which makes sense because otherwise the battery would be trying to power the system when it was turned off. So this arrangement of diodes and resistors over on the side here must have something to do with regulating the supply. Now, the chip itself, I can't remember the number off the top of my head, the real-time clock chip, this is the battery input up here. This is pin 18, the last pin, and this runs to I'm not in properly, there we go. This runs to the joint of this resistor and this diode, and I have gone through and written this out as a schematic. So here is that joint between this diode and this resistor. This diode is joined to this diode, comme ça. And this diode is joined to this resistor, this one here, there we go, and the top end of this resistor goes to the plus 12 volts from the motherboard. This second diode here is actually connected to the plus 5, there we go, plus 5 line, and they're oriented in such a way that the 5 volt line obviously you don't want that to be charged by the 12 volt line, so this is obviously oriented in such a way that the cathode is attached to the 12 volt line above this, across this resistor here, which is off camera now, but that's 470. In fact, they're both 470 ohms. Not that I think that makes any difference. And incidentally, the diode drop, don't have it in diode mode, hold on, there we go. I suspect these are Schottky diodes. The diode drop across them is 0.6 volts. Anyway, so ultimately, and then what I should say is that the bottom end of this resistor, is this the one here? The bottom end of this resistor is the one that actually connects to the battery positive side. So under normal operation, when the power is on, you'd be receiving 12 volts through effectively a resistor divider and the battery and a diode, and that is what charges it. Now that seems a little bit haphazard for my tastes, but these are old Amiga batteries and they can put up with a lot. In the event of an absence of the 12 volt line, the 5 volt line would do the job. Quite the purpose of that, I don't know. I'm not enough of an Amiga expert to know whether 12 volts is occasionally not present, or don't know, don't quite understand that. And that would charge the battery and obviously power the chip from VBAT. I mean, it does also have VCC, so I don't really quite understand that. I presume it is purely just incidental that it charges or that it powers the VBAT line if VCC is present on the chip elsewhere. Now, in the event, and this is probably just to limit the current, it's not really a voltage divider because the battery, I suppose, it would be here and to here. Maybe that's just to stop this being over voltage when the 12 is connected. Again, why the 12? I don't know what the voltage of this battery was. Anyway, that was obviously the circuit when that's switched on. So when it's switched off, on the other hand, you have no input on this side, but you can draw a line here because this diode then becomes effectively negatively biased by the positive end of this battery, rendering this completely irrelevant. So then VBAT is attached purely through a 470 ohm resistor, and then ground is common between here and here. So if we're fitting a non-rechargeable battery, which is my plan, then obviously the negative, the cathode, can be put into the same hole. Incidentally, no. Well, I suppose you could. The pitch is correct to get the battery in place, but yeah, look, it doesn't really work with the chip position. So my suggestion would be to mount the negative terminal there and the positive terminal off the edge of the board here to allow us to route, basically hot glue that down, and that'll allow us to bodge wire that side into wherever it needs to go. And all we'll do to avoid this entire charging malarkey here is to remove this diode, and that will effectively, like I said, as if it were basically negatively biased, it completely eliminates that top circuit. So I think that is sufficient. We only need to remove the one diode. That's my plan, and they've all worked really well so far. Oh yes. So I think what I'll do is I'll try and add a bit of solder, melt it, and then just lift the leg. Out she comes, there we go. Okay, this is my B grade way of doing this. So this is actually just a little slice of hot glue, cut off and laid on the PCB, and then I bring in the hot air gun set at 160 and very low airflow, and and I'll blow it straight on the floor. Perhaps even less airflow than that is required. There we go, doesn't take much to melt that. The clip side is the positive, and the bottom shell is, I believe, the negative, so we put the negative leg into there. We'll squish that down. I'm going to turn that so that it is basically taking up the least footprint possible. We'll just hold that in place for a few seconds while the hot glue cools a touch. There we go. And if I flip that over and show you how that looks, all we now have to do is to introduce the positive pin up here to the positive terminal. That's a bodge wire surely I can't mess up, even after the previous examples. Oh, what am I talking about? I'm sure I can. Okay, so lessons learned. I'm going to do some measuring before I put any batteries or even the RTG chip back in. So here we go, we're in place, and there is no battery, there is no RTG chip. But what I want to do, power's coming on, there we go. What I want to actually do is to just measure the voltage across these terminals here. Okay, we started with something, we died away. That looks like it's probably just a capacitor discharging. There we go. Yeah, there's nothing there. I think I'm just sinking a capacitor charge. So that's good. So there's no danger of us oh, gosh, sorry, I'm pressing buttons underneath and the square waves just come up. What I was trying to say was that I don't think there's any danger of us charging the battery. That's absolutely fine. Okay, RTG in place. CR 2025, because I don't have a 2032. There we go, that's in place. Now that should therefore provide us with some voltage on the which way can I fit this in? There we go. We should have some voltage now on that pin. There we go. 3.3 on the these are connected together, but that's the crystals that aren't used. 3.3 on the VBAT. So let's have another go, shall we? Well, unfortunately, as with so much in this in this little tidy up build, that hasn't really worked properly. Yep, no, I've done something wrong again. You'll see that the seconds aren't advancing. So 40:37:48. 14:37:48. Now the interesting thing is that I set this yesterday, which was a Friday, August the 30th, late o'clock, and it has advanced. It's close. It's actually only about 10 minutes out, but it's not advancing when it's turned on. So to me this suggests that it actually is running. The battery is doing its job when the power is off, but when the machine is turned on, it basically isn't running. I tried booting Workbench and it said there's no clock available. So what I've effectively done is chopped off the top half of that circuit there, so that the so VBAT is always connected to the battery, or is always driven by the battery, and so drops about, we saw about 3.8 volts we saw it drop to, didn't we? where we saw it, you know, it's constantly at 3.8 volts. But I wonder, I haven't really read the data sheet properly, I wonder if when the power comes on, it expects to compare the voltage of that pin with its actual chip driving voltage, and if they're not sufficiently similar, it considers it in a hibernation state and just keeps itself ticking over in the background without actually servicing the real-time clock element properly. I don't know. So it's possible I need to restore this and instead just insert a diode after the battery here. Insert a new diode there to stop the battery being negatively biased. So we'd restore this diode and we'd put a new one in where probably I've put that bodge wire across the bottom. We'll replace that with a diode instead. I mean, goodness me, will anything actually work in this video? Well, as luck would have it, in my parts bin I happen to have some 1N5819s, which are indeed Schottky diodes. And if we have a quick look at the voltage drop across them, .2 volts, that is pretty good. That means that we get the most life out of our battery, basically. So let's have a go at fitting that. Okay, right, so where are we now? Is this attempt number 17? I'm not entirely sure. Let's give that another try, shall we? Okay, I'm struggling to fit this all on the screen, so I'll put the meter into min-max mode and we'll do some measurements. So we do have a battery in place, and I'm going to measure now from the negative terminal, and the power is on, I should say, and we're running the test kit again. So the power is on, and across the original battery terminals I'm getting a figure of 5.3 volts, which would have been obviously the back charging voltage. So what about across the new terminal? So here's the real positive terminal. 3.4, which is obviously the battery voltage. So perfect, we're not seeing any back charging going on there. Okay, so there we go, white screen. Test kit only takes a couple of seconds to boot up. There we go, right, F8. Chip detected at DC00, and it thinks it's Christmas Eve 1984, which is probably actually the time a lot of people were getting ZX Spectrums. Let's, or well, a day later by the look of things. Let's do the F1 reset. There we go, set date and time, and I'm going to look up what the current time is. So we are August. Got to scroll all the way through because it's the 31st. Sorry, I'm probably bouncing the camera. I'm going to go with 2024, and I'm going to go 15, 16. Let's go 15, 17. There we go. Escape is save. And now we're seeing it advance. So I think there must have been something about that. Perhaps like the power loss detect feature or something like that, so that it only actually uses the battery when it needs it, perhaps. I mean, I didn't worry about that because, you know, if it's going to keep the battery when you're powered off for so long, then I thought, what's the harm in having it connected all the time? But it shows I don't know what I'm talking about. Not for the first time in Amiga land, and yeah, to be honest, I've only just got a Mega ST, which has a real-time clock, so I've never had to worry about that before either. So finally, there we go. Time has passed, and success. The second hand's even ticking, which, well, that's a big improvement on where we started. Hello, this is just an interjection from David in the future. Whilst that all worked and I went on to finish the video with it working fine, I just had a nagging feeling in my head that I still don't understand how this circuit quite works here, this old charging circuit across the top. From what I can see, 12 volts is coming through this resistor, 5 volts is coming through this diode, that's going to be effectively irrelevant because that voltage is always going to be higher than on that side, so that effectively becomes isolated. That diode, okay, drops 0.6 volts off the 12 volts there, and then we've taken this out. Well, we've got our diode in here, but I mean, effectively, again, there's no current going to be flowing through there because this is going to be 3 volts coming in this way, and this is going to be sort of 12ish coming down here, or at least more than 3. To me, that looks like we're putting a lot of volts into VBAT there. Now, I've done some measurements in situ, going to this pin up here, and it comes out as exactly 5 volts. It's really well regulated. Incidentally, it's supposed to be a maximum of 7 volts that goes into this chip, and I can't quite work it out. How is that getting down to exactly 5 volts? Is there some have I worked this out wrong? Is there some sort of what's it called, voltage clamping going on with the diodes here? I don't quite understand this. Or perhaps there's sufficient current being sunk through the chip that it's drawing down to the equivalent of a voltage divider with the 470 here. I don't get it. So what I thought is, as just an experiment, I'm going to remove this 470 ohm resistor here, so that we're only powering through the 5 volts with a double drop, so it's going to be 4 mumble volts. Is that sufficient for the seconds to tick over, as we saw, you know, when it was just powered by the 3 volts? That wasn't enough. Is that going to be sufficient for that to tick over? And if it is, I might leave it like this, because I simply don't understand this, and without a battery to charge, I'm just worried. I don't want to over voltage that chip. So what I'm going to do is whip off that resistor, which is this one just here, and I'm going to give that a quick test. Okay, so this is a little bit of a clumsy test setup, just on account of I'm on the side bench here for this. So with nothing turned on, what I'm doing is just going to measure from ground over in the corner here to my battery. There we go, 3.08 volts, and that's going to the pin there. Is that pin 19? I think. There we go, 3.02. That's the voltage in. So let's throw the switch, turn on the Amiga. Right, so I'm still getting my 3.0 volts, 3.08 volts on the battery there, which is good. That means that the diode is doing its job. So what do we have now on pin, the end pin here? There we go, we've got 4.07, so that's that double diode drop. But it does mean that the 12 volts, which I think is there we go, is no longer being passed through via any mechanism. So the question is the 4 volts enough to have it tick over? So that has booted Amiga test kit. Let's have a quick look. There we go. So we're going to go into the RTC F8. No clock detected. So well, I think that answers that question. I don't get that circuit at all, but it does appear that it's required. Okay, there we go, with the 470 ohm resistor pack, 5.03, bang on. Yep, I don't understand how that works, but fair enough, it does. Well, true to form, I think we can say that was a bit of a disaster, that. So, taking out the chip, we lost 3 pads, plus their through-hole plating vias. I then failed to connect one of the bodge wires entirely, and soldered the second bodge wire up here to completely the wrong data pin. I then performed a clever mod for the CR2032 battery here, which resulted in the chip maintaining its clock when turned off, but just actually not counting when turned on. But on the positive side, we did clean up the corrosion around that chip there. It now is all nicely socketed up. We've fitted a lithium primary here, and with the second attempt at the mod there, we have restored the board to full functionality, with the exception actually of that enable disable switch on the bottom, which to be honest I don't really care about at all. Anyway, look, the connector's even smiling now. So I think my next adventure into A500 territory is actually a bit of a trip to the bathroom, and we'll get this scrubbed up a little bit. We'll have a bit of a cleaning job on it, and well, hopefully the next time you see her she'll be a little less green around the gills. She really is quite filthy at the moment. Anyway, there we go. We're all done for today. Thank you very much for watching, and well, I hope you found that interesting, if not actually a little bit hilarious. See you next time.